Today we are going to discuss the projection of the forces acting along the axis of the inclined surface and perpendicular to the axis of the inclined surface. Okay, so let's start.
So first off,
Mm-hmm.
mg, the gravity, will be going straight down no
Mm-hmm.
matter which direction the object is facing.
Mm-hmm.
And then the projection of gravity on the x-axis.
Let's first show all the forces that they are and then do the projections.
Okay, then we have normal force.
Okay.
So this is Fn.
Mm-hmm.
And then we also have that right there.
Okay. The friction, right?
Yes. How do you want me to denote it?
Like small letter F. Okay,
Okay,
again,
so
again with the vector, and also mg with vector.
yeah, and then that's mg. So now the other forces we
Let's
have.
also show the axes that we should
Yeah.
project on, right?
So first we have the y-axis,
Mm-hmm.
and then the x-axis, and then we should also draw the other parts to it. Okay.
Okay.
So the projection of gravity on the x-axis gives us Fg,
Mm-hmm.
and then we can also project gravity onto the y-axis here.
Mm-hmm.
And that one is
We denoted it
uh,
M, small
wait,
letter
with
M.
what?
M, small M letter.
Wait.
Again with vector sign because it has direction. Okay.
Yeah. So
And also let me
uh,
remind you, we have an angle of alpha here.
yeah. Hold on one sec.
Okay.
So if we look at this triangle here, um, which one was the circle? Yellow triangle.
Mm-hmm.
Here we're trying to find a couple different angles. We know
Mm-hmm.
this is a right angle, so this
Yes.
is 90 degrees.
Okay.
And we're trying to find this right here,
Okay.
which this will be denoted as alpha yellow.
Okay.
So if we want to find alpha yellow, we need to use alpha 90 degrees and alpha yellow, and these will all equal to 180, which is
The
um
summation, right? This,
yeah, the sum of a triangle.
yeah, some of the triangle angles. Yeah. Okay.
So that gives us alpha yellow plus 90 degrees plus alpha is equal to 180.
Mm-hmm.
And since we want to get alpha yellow by itself, what we can do is just
Mm-hmm.
that's how you get alpha yellow.
Okay.
Now, uh,
Alright. By the way, we you didn't show the angles. Whenever you are doing the projection, would you remind how much angle it makes with the axis that you are projecting on the line of
this one
projection?
here.
The angle, like these angles. or this angle? How much is the degree here?
Oh yeah, so the one here is 90,
Mm-hmm.
and then we have one right here as well.
Mm-hmm.
And then so we could denote this one as a blue triangle. So let me
Okay.
color that in really quick. So the angle we're trying to find for this one is this right here,
Mm-hmm.
which we'll denote as alpha blue.
Okay.
And we know exactly what we're working with because right here we have alpha. We just found this, or we have alpha yellow, which we just found, and then
Yeah.
a 90-degree angle right here.
Okay.
So what we're gonna do is we'll do it under alpha blue.
Blue is a subscript, right? We can write like a subscript.
Yeah, and then we're gonna add 90 degrees
Mm-hmm.
plus alpha yellow, which should equal to 180. So sum of the angles of a triangle.
Mm-hmm.
So now we can put blue plus 90 plus what is now what we found yellow, which is 90 minus alpha.
Yeah, we are just plugging this alpha yellow right here.
Yeah. So if we do all of the things, just algebra, we'll get alpha blue is equal to just alpha.
Okay. Okay.
Okay, and then now we're going to try to find alpha green,
Mm-hmm.
which, if I'm correct,
Would you show the triangle, the green triangle that we are going to consider?
yeah, one sec. Sorry. Alright, so the green triangle, it will be this one right here. And
Mm-hmm.
we're going to be trying to find this right here, which is alpha green.
Okay.
So here the thing, we have a 90-degree angle. And
Mm-hmm.
then right here we have this angle as well, which is, I think, just the same as alpha yellow.
Um, the same as yeah.
Yeah, because it's on the opposite side.
Okay.
So if we want to find alpha green, it's going to be alpha green is plus 90 degrees plus alpha yellow is equal to 180.
Mm-hmm.
And this is the same exact problem as from alpha blue, so we know alpha green is just equal to alpha.
Okay. Okay. Again, let's take it in the bracket.
Yeah.
Okay, so now what we are doing. First, let's try to find FG, the projection of MG on x-axis.
Yeah, so FG is the projection, which means FG would be equal to mg times sine alpha.
Um, yeah, you're right, but can we first see how does it work? Like here, you have this angle alpha, right?
Mm-hmm.
And you know that, can you write just what is sine alpha equal here? Like
Yeah, so
opposite to hypotenuse, like this.
yeah, okay. sine alpha is equal to um, opposite over hypotenuse, which on a triangle you can tell because the opposite is the one on the other side from the angle, and then the hypotenuse is the one away from 90 degrees.
Okay, in front of 90
And
degrees.
it's also the longest one.
Yeah.
So um, sinus alpha is equal to our opposite, which is FG,
Mm-hmm.
over our hypotenuse, which is MG.
Yeah.
And if you want to take MG by itself, it would be FG by
FG.
itself.
Yes.
FG is equal to MG times sinus alpha.
Okay. Okay, good. So we found Fg, the force acting on the object along the x-axis. Okay. Now let's understand how we can find the normal force, Fn.
Yeah, so to find Fn, we're going to use cosine alpha
Mm-hmm.
since
Again,
this
which triangle? Are we
the
using?
green triangle.
Okay.
So this right here.
Okay.
And so to find it, we're going to use the hypotenuse
Uh-huh.
and the adjacent.
Yeah.
So cosine alpha is equal to
M.
the
We denoted it M, right? Yeah, okay, you can
yeah,
write. Yeah, you are right. Adjacent over hypotenuse, yeah.
adjacent over hypotenuse. So cosine alpha is equal to we're gonna use m for it, so it'll just be
Yeah, M.
m over mg.
And M is here like force. We cannot cancel it with the mg, so we
Yeah,
can just
because
keep
this
that.
one's mass and this is a force,
Yeah,
so you can't cancel that. So cosine. Wait, no, here. So if we want to find m by itself, it would be m is equal to mg times cosine alpha.
yeah. And this M is also equal to the normal force, right? Because the object is not moving along the y direction. It means that the forces should be balanced. So we also have Fn, which we just can write like this. Fn is also equal to mg cosine alpha, right?
Mm-hmm.
Okay, so we also got this. So here we got all the projections. But the next question is to find what will be the friction. What do you think? If the object is, let's discuss two scenarios. The first one, if the object is not moving.
Well, if the object is not moving, that would mean that it is static friction, which means F is equal to Fg.
Yeah, can you
The
write it
two
down?
forces are equal. Yeah. So if the object is not moving, F is equal to Fg,
Which is equal to
which is equal to mg sine alpha.
yes. Okay. So and the second case is if the object is moving, object is moving and the coefficient of kinetic friction is nu k.
So if the object is moving, it would be kinetic friction,
Mhm.
which would mean that we would have to use this equation to solve it, which is Fk is equal to Fn times what was it again? Times
This mu k,
yeah, mu k times mu k And if we were so um how we would do this is we would have to use Fn.
Mm-hmm.
Yeah, so Fk is equal to mg cosine alpha times mu k.
Okay, good. So all the force is found.
Yep.
Okay, thank you.